Like the human body and its vital organs, ships rely on a circulatory system to feed essential liquids and gases to the equipment and devices that allow the ship to function properly. And valves are a key element of these piping systems. In fact, valves are the most important element of a piping system because they regulate the flow of fluids by opening, closing, or narrowing their passages. To avoid confusion, colored paint or tape is applied to each piping system to identify the fluid being carried within. The type of valve used for a particular piping system will vary according to the fluid handled. This is because each fluid has specific characteristics and conditions of use, such as temperature, pressure, and flow rate. This DVD will introduce you to the types and structures of valves commonly used on board ship. Although valves come in many shapes and sizes, they share two common external elements. These are the pressure vessel and the handle. The pressure vessel consists of a valve body and a bonnet. Let's take a look at the parts and components of a valve. The body is the valve's main component. The body can be made from a variety of materials. The choice of material depends on the pressure, temperature, corrosion resistance, and other conditions of use. Most valve bodies can be classified into two types: those for collinear flow fluids and those for right-angle flow fluids. The bonnet is made from the same material as the body, but its shape varies according to pressure specifications. Most bonnets are joined with a flange, but some are joined to the body with a box screw. The bonnet structure has a packing box, known as the gland, designed to prevent pressure leakage from inside the valve. The gland is a vital part of the valve. The valve seat and disc. The valve seat and disc are the heart of the valve. The latter adheres to the former. Shapes and materials are determined by the specific conditions in which they will be used. The stem. The stem is a mechanism for opening or closing a valve by means of pulling up or pushing down on the disc. There are two types of stem. One moves up or down while rotating, and the other moves within 180 degrees of the shaft center. The up and down and rotational movement of the stem can cause the fluid inside the valve to leak out from the sliding part. To prevent fluid leakage, a gland is used to hold internal packing in place by allowing the gland flange to uniformly press down the packing. The sleeve. The sleeve is an encasement that bears the thrust to which the stem is subjected. Nickel bronze is widely used for sleeves due to a high tensile strength that offers excellent bearing performance. The handle. The handle is manually operated to open or close the valve. Generally speaking, a clockwise turn of the handle opens the valve while counterclockwise turn closes the valve. The actuator. Some valves use an actuator in place of a handle. The actuator is a remote control actuating system using electric, pneumatic or hydraulic motive power. Now let's take a look at the structures of valves commonly found on board ships. The globe valve is so named because its body is shaped like a globe. Inside the body is a barrier plate. The centers of the inlet and outlet ports are aligned, and the fluid flows in a figure S. The globe valve structure is designed to stop a fluid from flowing by turning the handle to press a disc against the barrier plate seat. The disc shape is flat or conic. By changing the disc shape, the globe valve can be used in either control motion mode to control the flow or in on-off motion mode to open-close the valve. Since pressure loss within a globe valve can be significant, this type of valve is not used for fluids of high viscosity. The gate valve structure is designed to partition the fluid flow. A turn of the handle rotates the stem and moves the disc up and down at a right angle to the flow passage, opening or closing the valve. The fluid advances almost in a straight line, minimizing pressure loss. This type of valve makes use of the disc's wedging effect to stop the fluid flow. It is used in on-off motion, that is fully open, fully closed mode. In this mode, a counterclockwise turn of the handle raises the disc and allows the fluid to flow, while a clockwise turn of the handle lowers the disc and causes the fluid to stop. If the valve is used while half opened, the fluid flow around the disc changes abruptly and may lead to corrosion or erosion. The check valve is used to prevent fluid backflow by constantly keeping a fluid flowing in one direction. The disc is pushed open by the fluid's pressure. When the fluid flows back pressure presses the disc against the body seat, thereby preventing flow in the opposite direction. Check valves are used to prevent damage due to reverse rotation of the pump or compressor, or due to a fluid's backflow into a low-pressure section. There are two types of check valve, swing type and lift type. With the swing check valve shown here, A tip of the disc is suspended from the valve body like a hinge, so that it moves freely in the direction of the flowing fluid. The fluid is allowed to advance almost in a straight line as the disc swings up by approximately 60 degrees from its vertical position. When the flow comes to a halt, the disc's weight returns it to the vertical closed position. When pressure is applied from downstream, the disc is pressed against the valve seat, creating a seal and preventing fluid backflow. The structure of the swing check valve is designed to minimize pressure loss and allow smooth flow of the fluid. This makes the valve suitable for use in horizontal piping as well as vertical piping, in which the fluid flows upward from below. Swing check valves are used mainly for large diameter pipes. Its disc shape is flat. When a detached valve needs to be reattached, pay attention to the direction it is facing. If it is facing in the opposite direction, the disc will malfunction. The structure of the lift check valve is that of a globe valve without a stem, handle and other parts for opening-closing operation, and to which a cover has been added. The fluid flow pushes up the disc. As the flow comes to a halt and back pressure is applied, the disc is lowered and comes into contact with the disc seat, thus preventing fluid backflow. The disc is either conical or cylindrical. The disc motion is straight and parallel with the direction of fluid flow. Because of its significant fluid resistance, this type of valve is used for small diameter pipes. With the bull valve, its disc is bull-shaped and a soft seat is incorporated in the body's valve seat. The lever-handled type bull valve is opened-closed by turning the lever handle 90 degrees. While the soft seat material used in the bull valve offers excellent air tightness thanks to its mechanical and physical properties, it does have its limitations when it comes to high temperature applications. The bull valve is suitable for on-off motion opening-closing operations using a generally available soft seat, but it is not suitable for semi-open, semi-closed operations. The butterfly valve has a simple structure. Inside its short cylindrical body, the disc has a seat surface around its circumference that turns 90 degrees with the stem as the axis. The disc can move within 90-degree range, driven by an external worm gear. Due to its structure, shutting off of the valve seat has been considered difficult to do. But complete shutting off has become a reality thanks to improvements to sealing materials and their shapes. Furthermore, improvements to the shut-off mechanism, such as disc shapes and stem positions, now enable fine flow control. With this experiment apparatus, you can see a butterfly valve of a special shape performing fine control of fluid flow with a slight opening. To develop high-quality materials and high valve performance, butterfly valves used on board LNG carriers are subjected to low-temperature tests by immersing them in liquefied nitrogen of -196 degrees Celsius. Shown here are various types of valve for LNG carriers. In fact, a variety of high-performance butterfly valves have been developed. Minimized face-to-face spacing makes the valve compact, lightweight and easy to attach-detach, meaning greater economy, especially for large-size valves. However, the valve requires careful operation because its flat disc can cause water hammer and unbalanced torque. This valve can be used for either control motion requiring flow regulation at semi-open or for on-off motion for full opening-closing. There are three types of special purpose valve: control valves, regulating valves, and safety valves. The control valve is designed to allow or shut off the flow of fluids, such as liquid, steam, or gas. Flow control is its main purpose. It consists of an actuator that is moved by external motive power in response to signals from a controller, and a body that has a restriction mechanism for flow control. Control valves are largely classified by type of driving element power source: pneumatic, electric, hydraulic, and self-actuated. Many control valves use disc actuation based on changes in air pressure and adjust the gap between the disc and seat with a spring or diaphragm. Depending on the purpose, position, temperature, pressure, flow velocity, and type of fluid for a given application, globe valves, angle valves, three-way valves, or rotary valves can be used as a control valve. These valves are divided into single-seat and multiple-seat types. In terms of the relationship between disc motion and pneumatic pressure, some valves become full open at zero pneumatic pressure, while others become fully closed at zero pneumatic pressure. The regulating valve regulates pressure, flow rate, liquid level, and temperature. It is suitable for controlling tasks that do not require a high degree of accuracy. A spring is used to set target values and read deviations, while a piston or diaphragm is used to actuate the valve by amplifying the fluid pressure. The energy required to actuate the valve is obtained directly from the process fluid. Hence it is known as a self-actuated valve. Regulating valves come in direct acting and pilot-operated types, and many have a globe disc. Safety valves are used to ensure the safety of steam or gas generators, pressure vessels and piping. These valves are automatically actuated when the valve inlet side pressure rises, blowing off a certain amount of steam or gas when the prescribed blow-off pressure level is reached. There are two types of safety valve, the spring safety valve and the safety valve with a pilot valve. So far we have explained valves commonly used on board ships. There are many other types of valve, all playing the common role of efficiently controlling fluid movement in their respective ways.